notes. Section 5.5, adding and subtracting polynomials. We're going to go back to some old stuff that we did in the first semester and kind of build off of that. Most folks find this to be a pretty attainable thing, something you'd be very successful with. And so I hope that's the case. We'll do some work at the board with this as well. I want you guys to start off with number 1 right here, how to add like terms. So I'm just going to turn you loose. Just try this. If you know how to do this one, it shouldn't take you too long. 4x to the 4th plus 81x to the 4th. Please add those, and we'll do number 2 in just a second. Brian, what do you think it is?
I did 85x to the 4th. 85x to the 4th. So you obviously left the exponent the same. Yeah.
And you added the coefficients.
Yeah.
Perfectly done. Well done. So he didn't do anything with the exponents other than leave it alone, added the coefficients, and he's good to go. Does that seem like something we've done before?
Many times.
Many times, that's right. Okay, so number 2, a little more complicated, yet similar concept. Let's add the like terms in there. Obviously, there's a little more going on. See what you can do with number 2. Again, something we've done before, but a little more complicated. Try number 2. Okay, Emma, can I get your answer?
Is it 13x to the second, and then 2y to the second, and then
You said and then something and I lost you there.
y?
You said and then. Like, I don't know what to put for and then. Like,
Just y.
so just y right there?
Yeah.
Okay, gotcha. Sorry, I just was a little confused. Okay, what do you guys think? Good answer, bad answer, close, far away? What do you think, Braden?
I got 13x squared y squared plus y.
So like that?
Yeah.
Okay, fair enough. Joel, what do you have?
I have 13x to the second plus 2y squared plus y.
Plus 2y squared plus y. Did I write that down correctly?
Yep.
Okay, very good. Ben, we'll get to you next, Will.
11x squared y squared
I had.
plus 2x squared y.
That is what I have then.
Some agreement on, we're going to say the same thing, Will?
No, I have something.
Okay, what do you
I
got?
said it was 13x squared and just y.
13x squared y.
That's what I got.
Okay, Will.
I said it was 13x y to the fifth.
Oh, 13x y,
13x squared y to the fifth.
x squared y to the 5th. Okay, so we got 1, 2, 3, 4, 5, 6 different answers up there. Anything else?
That close.
Perhaps the right answer is still not there, Joel.
Oh, is it 11
I'm allergic to that.
x to the second y to the second plus 2x to the second y? Oh, wait, no, that's okay.
That's the same. That's the same as that one, kind of in the middle there.
I think we got it right. I can't remember.
Okay.
Mr. Anderson. I think I know the correct one.
Okay, what do you think the correct one
I
is?
think it's 13x squared, and then I can't see where it is, but 2y squared, and then plus y. So I don't know where that one is. Oh, there it is.
Which one?
Joel's. This one right here.
You think that one's right?
Yeah, I think that
Okay.
one's the right one.
All right. Will, did you have something you wanted to add?
Yeah, I changed my mind, and actually, I think it's 13x squared y to the fourth plus y.
13x squared. Was yours this one right here?
Yeah, it was, but then I didn't read it right,
So 13x squared y to the 4th,
and then plus y.
and then plus y, like that.
What is it? I'm dying to know.
Yeah, I know. Yeah. So
Right up here.
okay. So the correct answer, I'll highlight it, put it in a box here, I guess, is right here or right up there. It was the one that was mentioned twice. So what I think is interesting here, can you see we need a little bit of work on this, don't we? We had like 7 or 8 different answers up there, one of which was right, but there were others that were not as good. So I'm going to erase all of them, and we'll work through this together as far as what makes a like term, what makes like terms like, and how to combine them. We'll get rid of all of them. We'll come back around hopefully to the right answer. So maybe you guys saw this in middle school. Maybe you didn't. Maybe you saw it a different way. Here is a way to do it. I've got 3 different terms up there, right? And all of them are sort of complicated. What I'm going to do is I'm going to use some shapes to help me kind of get them organized. I'm going to put a box around this first term, and I'm going to look through the other 2 terms and try to decide, are any of the other terms like that one? So I look at this middle term right here, and I got to ask myself, all right, is that term like the first term? And the answer is no. What is the one symbol or the one reason making it no, Haley?
The y doesn't have an exponent on it, or doesn't have a
Yeah, it's a 1, right? It's not a squared. Yeah, so that makes that middle term, just that one little difference in the variable exponents there, makes this not a like term with the first one. Then I look at this third one, the last one there, and I ask myself, is that a like term with the first term? And it is, because both terms have x squared, y squared. And so I'm going to put a box around that one. Any 2 terms that are... Guys, listen up, please. Hey. I want you to hear this. Any 2 terms that are boxed mean that they're like terms. And then the way that you add like terms is you leave the variables and the exponents the same, and you add the coefficients. So 17 plus negative 6, that's where we got that 11. Right? So it would be 11, and then you leave the variables and exponents the same. And then we're left with that last term. You know, we could circle it if we want, but there's only one term left. There's no other term to be like it. So plus 2x squared y, and that's it. Okay, so a lot of effort in there. Question, yeah?
How come it wouldn't be 2y to the second on the first term after you simplify it?
Oh, because it's a y squared and then there's another one?
Yeah.
Good question. So, let's see here. We could use numbers to prove it if you want.
Yeah.
You know, so if you had something like, this would just be a way to, let's see, let's go, if you had, say, 3 times 2 times 5 plus, I don't know, 4 times 2 times 5. So those are like terms, right? Because they're both 2 times 5 terms. So it would be 7 times 2 times 5, technically. You're thinking that it would be 7 times 2 times 2 times 5?
Times 5, because there's 2 of them.
Right, that's where I got this 2 right here. That would kind of follow the pattern that you mentioned. So I guess what you could do is you could look at this and then look at these 2. You could use your calculator to calculate them and you'd see that this was the right one. That's a way to compare, I suppose. That makes sense? That's the best I can come up with for a y on spur of the moment. Good question. Okay, so I'm going to do one example for you. I'm going to have you try one at your seat, and then we're going to go to the board again and see how we've kind of internalized these a little bit. So we're going to add polynomials, and later on we're going to subtract and multiply and divide and do all the other operations, but today we're going to focus only on the addition of polynomials. So here are the steps. We're going to do the steps here for you, and I'm going to have you guys try this on your own. When you are adding polynomials, and by the way, I don't want to just blow past this, how do I know that I'm actually adding the polynomials?
There's a plus.
Yeah, the plus sign right in the middle. I mean, let's not blow right past that, because sometimes that'll be a times, other times it'll be a minus, and of course those things all mean different things. So when you are adding polynomials, here's what you do. Here's what you do. You simply drop the parentheses and add like terms. So step 1, parentheses get dropped, so 3c squared minus 2c minus 5 plus 4c squared minus 7c plus 3. And now we go through and add our like terms. So let's practice this. What is like the 3c squared?
4c squared.
So when you add those up, what do you get?
7c squared.
That is correct. All right, what is like negative 2c?
Negative 7c.
Right, and when you add those up,
Negative 9c.
that's right. And then the final terms are constants. Negative 5
And 3.
is like the 3, so you get...
Negative 2. Oh, we did it right there.
Okay, let me ask you a couple of quick follow-up questions, and I'll have you try the next one on your own. What is the degree of that final polynomial?
2.
Degree 2. What's the lead coefficient? 7 is right. And what kind of, like, what would you name that polynomial?
Polynomial.
It's tri. There's three terms, so trinomial. Brian, your question.
What does add vertically mean?
Oh, we'll get there.
Okay.
We'll get there.
Because I'm wondering if that's any different than adding.
So it's the same concept, just a different technique.
Oh.
Yeah. All right. So, guys, let's go ahead and jump to the number 4 there. Instead of doing it on the board, let's do it at your seat. Let's just do it by yourselves, and then we'll move on to our last couple, and we'll be back to the board.
Minus 3 and then minus 2x.
I'll put the answer up here. I walked around and I saw a ton of good answers. There's one or two folks that I didn't get to in time, but the answer should be 14m squared minus 2n squared minus 3mn. And so the order doesn't really particularly matter there. So if maybe you flip the last two terms around or something, that's totally fine. Never mark that incorrect. And that would be it. So like I said, I walked around, the majority of folks had that. Are there any questions?
Oh, restroom time.
Yep. Okay, awesome. Well then, let's take a look at numbers 5 and 6. Let's focus on number 5 for the moment. We'll get this closed up here in just a second. So, I know that problems like number 5 have given us a challenge in the past. It's geometry, so I want to make sure that you all understand what is the concept of perimeter. What is it?
It's just all the sides added.
All the sides added. So perimeter is distance around. So to get the distance around a geometric shape, like Ben said there, you're just going to add up all the sides. So with a question like number 5, it says find a polynomial that represents the perimeter of the trapezoid. It's kind of a classic trapezoid look there. If you guys have done a little geometry, maybe you recognize that. But to find perimeter, we simply need to add up all the sides. And as you're doing that, make sure you simplify by adding up your like terms. Ready to go? Down the setup here, you guys can feel free to check or keep working if you're on a roll and doing okay. So I've completed that setup. Feel free to compare. I need to still add my like terms, but that would be, I think, a good setup. Say again?
I just went around, like I did the terms, I just went around.
Right, you kind of like group the like terms as you went.
Yeah.
Yeah, that's fine. Not a problem. Okay, so let's get one last chance with practice with this. So I'm going to ask you guys a couple of questions. Aria, what is like a squared?
4a squared.
Yeah, so there's a bunch of those. So Aria, let's keep going on this term right here. If you combine all those like terms by addition, what do you come up with?
10.
Yep, 10a squared is definitely correct. And then we got the a terms. So Haley, read. I've got that a term. Is there any term that's like a?
Negative 2a.
That's right. So when I try to combine those, what do we get? Negative a. Good. And then finally we got these two terms here, negative 5 and 1. Those are both constants, and so they are like terms as well. J, when you add those up, you get? Negative 4. Very good. Okay, so that would be the perimeter. What you could do with that is you could say if a is negative 2, what's the perimeter? Or if a is 7, what's the perimeter? You could actually figure out a perimeter based on our little formula that we set up there. We're not doing that here, something that could be done. Okay, and then the final thing I want to show you guys before we head back up to the board to finish off our board races for the day is number 6. I want to preface number 6 with the idea that number 6 is simply a just in case you want to do this method. This will never be a requirement. It's just in case, like the way that we've been adding the like terms with the colors and the shapes, it might be just an alternative method that would be good for you. I know in the other class, there's, there's like 15, 16 students in there, and of those 15 or 16 students, there was a handful that said, yeah, I actually kind of like the vertical thing. The others are like, yeah, I don't really care about it. Let me show it to you. You can decide whether you want to do it or not. So to add vertically, what you want to do is you want to, obviously go in a vertical fashion, but you want to line up the like terms. So if we were going to add vertically, we would write 8x squared plus 2x minus 1. And then we would take that 4x squared plus 5 and try to line it up vertically. So In other words, I'm going to look at this 4x squared and say, well, what should that go underneath? What do you think it should go under?
The 8x squared.
Yeah, because they're like terms. So you'd go 4x squared here. There is no x term in this other term, or the other polynomial. So you'd go plus 5 right here. If you wanted to put that, Matt, you could. You could write plus 0x in there if you wanted to. There's no requirement to do that, though. So then finally what you would do is you would add vertically. 8x squared plus 4x squared is 12x squared. 2x plus 0 is still just 2x. And then negative 1 plus 5 would be plus 4. That's just a different technique. Again, no way is that going to be required. Simply might be a method that's good for you. And if that is a good method for you, then you do it. And don't look back. Otherwise, you can do the horizontal approach that we've done before. So, all right, so that is it. When I see you guys tomorrow, we're going to do board races here in a second. When I see you guys tomorrow, we will look at subtracting polynomials. Similar to what we did today, but with one important difference, obviously being subtraction. So let's head back up to the board. We'll practice this right now.